Good evening to you all who are watching this video. You're welcome to our channel, Electrical Explained. So in our comment sections, we got someone who was asking if it so happens and we excite our generator with AC, what would be the outcome? So basically this video is recorded best to give a reply to that question. So we urge you to continue bringing in such questions. We shall always try to respond to each and everything that we can possibly do so. So like it's basically like a principle, but we are going into detail to see why it is so. Why we have to excite our generator with DC. Basically, a DC waveform voltage is a straight line, and as for the AC waveform, it is a sinusoidal wave, DC, and this is our AC. So at this point where we have the positive and negative connected, it's where we do apply the DC current to excite the stator. So after exciting this stator, we are basically introducing a north pole and the south pole within the stator. South pole within the stator. So if we have a permanent north and a permanent south, we shall have field lines. Moving from north to south. For as long as we have the DC supply, we shall always have these magnetic field lines. If this is the rotor, so this is a winding within the rotor, and on this side it is coupled to a shaft of a prime mover. This is a coupling. So if we have rotation at this point, we shall have our conductor rotating. So once this conductor is rotating, it will be cutting through the magnetic field lines between within the space within the stator. So in that way, we shall have on one of the sides of the conductor, we shall have current moving in that direction, and on the other side we shall have current moving in this other direction. Same apply to the output. Through these slip rings, we shall have current moving in one direction and moving in the other direction respectively. So that is after this conductor has moved from this point down, it has rotated and has reached this point up. After this conductor has reached this point up, the current, using the Fleming's hand rule, remember in generators we refer to the right hand, and in motors we refer to the left hand. So if you refer to the right hand, you will definitely identify which side the current that is generated within the coil, its direction. So for example, if I'm to use a red color ring, Now after this conductor has moved from this point to this point, initially we can see its current was moving in this direction. So when it reaches on this other side, so what was red here, when it reaches this side, it will change direction. Now it will be moving towards this side, and this that was moving towards this direction, when this conductor also has rotated through this other side and reached on this bottom side, it will now also change direction, and now will be moving towards this direction. And therefore within these conductors that are connected through the slip rings, we shall have it change direction, this one moving to this direction and this other one moving to this direction. So the cycle will continue for as long as this conductor rotates by 180 degrees. We shall have change in direction of the current flow, and that's why we shall have our output waveform in a positive, negative, positive, negative form. So the current flowing will be positive, negative, positive, negative, positive, negative. So at this point, say this is 0, at this point it has reached 180, so it changes from negative to become positive. It moves 180. When it reaches 360, it changes direction and becomes negative, and so on and so forth. And so that's how excitation with the DC works. And now if I'm to bring the same demonstration and I use an AC as an excitation, let's see what will happen. So still using the same demonstration, if we supply at this point with an AC supply, an AC voltage, thereby introducing an AC current to flow through this stator, what will happen? So between the stator, like we had said, usually for a DC we create a north and the south pole, and these are always permanent in this state unless you change and make this negative and make the upper one positive. But as long as we maintain that connection, then we have a permanent north pole and a permanent south pole within our windings. So if we apply an AC current, through the stator, we shall have, first of all, in the first cycle, during the first cycle of our waveform, we shall have the north. Say for example, we shall have the north on one side of the winding, and we have the south on the other side of the winding. And after changing direction into the negative half cycle, we shall have now the north shifting to the downside and the south shifting to the upside. So this changing and shifting will continue to occur, and the rate of this change will be dependent on the frequency of the AC that is exciting the rotor. And now if we are to see what kind of output we shall probably have, so during the rotation of our rotor, say for example at this point, this conductor moving from this side to this side, definitely there will be a magnetic field, and now our rotor will cut this field as it is rotating. So by the time it moves from the from one side, say it is at 0. By the time it rotates up to 180 degrees, it will have cut through the field that is alternating north to south, then south to north as they are changing position. So it will rotate several times. So as they are cutting and with the field rotating, because of the rotating nature of the supply that we have used to excite the stator, first of all we shall have, say for example, current moving in this direction, that is within this first half. Then within the other half we shall have the current changing direction, and then in the other half it changes to this direction, and in the other half it changes. Now in this last half it changes to this direction. So depending on the frequency of this sine wave, you may find that by the time it has moved from 0 to rotate to 180, it has the north has shifted to the downside, and then back to the north, and then back to the downside. Hence, by these currents that are being generated within a conductor, they will be changing. And what is happening within this side of the conductor is the same that will be happening on the other side. So as this one is in this direction, we shall have this one in this direction, this like that, like that. So you see, in the end, the waveform that we shall have will be of this nature. Say if it is it's starting from this side, V out. So as within the first 180 degrees, it has changed direction from 1 to 2, 3 to 4. So it will be 1, 2, 3, 4. No, actually, we first go back a little bit. It will change 1, 2, 3, 4. Then after reaching the 180, it has moved from 0 to 180. Now moving from 180 to complete the 360 degrees, it will now move 1, 2, 3, 4, and so on and so forth. So you see, the waveform that we shall have produced will not be a perfect sine wave like what is required by our machines. So this waveform will have a lot of harmonics, and it's not favorable for our machines and for our equipment. So basically, that's what we wanted to highlight today. You can give a thumbs, a like if you feel the content that has been shared has been so helpful. You can subscribe and comment and share as well. So good evening and have a blessed time. I hope you enjoyed. Thank you so much. God bless you.